Here we have the beginning problems from Chapter 5 on decimals. We're adding, subtracting, multiplying, and dividing them to start with. Here are our quick answers, and stay tuned for working them out. So again, we want to remember that there are adding and subtracting rules, and there are multiplying and dividing rules. The adding and subtracting rules with decimals are that we need to line the decimals up when we add and subtract them. So 26.5 plus 3.74, this lines up the ones column and the tenths column very nicely. So now we can just go straight through and add. And we get 30/24. 16 minus 2.89, well, 16 doesn't have a decimal. It's got an imaginary one right at the end here. So we have to make sure that we keep that decimal there when we line this up. And anytime we do subtraction, we do biggest minus smallest. We can't subtract nothing minus 89. We need to fill these zeros in and borrow from the whole so that we can subtract 10 minus 9, 9 minus 8, and so on. When we multiply and divide, we don't have to line them up. We have to keep track of where that decimal is, and we do that differently with multiplication and division. With multiplication, we're going to treat this just like a regular long multiplication problem, and we're going to add up all the decimal points at the very end. So 32.6 times 0.45, we don't have to line them up. We don't even have to keep track of them until the end. So we're just going to do this long multiplication just like regular. 6 times 5 is 30, 10, 13, 16, placeholder, 24, 8, 10, 12, 13, add them up. And I'm going to count places. I have 1, 2, 3 decimal points. So I have 1, 2, 3 decimal points, and my decimal actually goes there. In long division, when I set up the problem, 2.14 divided into 2.18708. I can't have a decimal point out here. I'm not allowed to. I need to move this out of the way. So if I'm going to move this 2 to get it away, I'm also going to move this 2. So my decimal in the answer goes up here. Now it's really important that I put my answers up here in exactly the right spot because it has to be in the right spot near the decimal. 214 goes into 218 one time. I've used this 8. So my answer is going to go right above that 8. 1 times 214 is 214. Subtract. I get 47. 214 goes into 47. No time. It does not go into it. So I have to put a 0 up there. And then I'm going to bring down my next number, 470 now. 214 goes into 470 twice. 2 times 4 is 8. 2 times 1, 2 times 4, subtract. And I get 42, and I'm going to bring down my 8. 214 goes into 428 2 times 428, and I'm all done. The second half of Chapter 5 is solving equations and then changing between fractions, decimals, and percents. Here are our quick answers. Stay tuned for working it out together. So we're going to start with solving equations, and we're going to first look at what's going on here because we have to do the opposite of whatever's happening to our variable. Well, in our first one, we have a 0.5 multiplied to our m. So we're going to have to divide each side by this number. Divide by 0.5. And that makes this go away. So we've got an m equals. And we've got to figure out what 0.6 divided by 0.5 is. So top number goes in the house. Bottom number goes out here. I got to move this over 1, so I've got to move this over 1. So this actually goes up here. That all goes away. How many times does 5 go into 6? Well, 5 goes into 6 one time. 1 times 5 is 5. Subtract, you get 1. I've got to annex another 0. I'm going to stick that decimal right in there. 5 goes into 10 twice. 2 times 5 is 10, and I'm done. So m equals 1.2. Here I have a 3.1 subtracted from my t, so to get rid of it, I'm going to add 3.1 to both sides. I'm going to line up my decimals. This goes away. T equals. I have a negative 5.2 and a positive 3.1. I have two different signs. I'm going to actually subtract these two. And I get 2.1, and the biggest one wins. So t equals negative 2.1. Here I have a 3 added to my x. I need to subtract 3 from both sides. But remember, I've got to line up my decimal, and that decimal lives right there. So I'm going to subtract 3 from this. I have a positive 0.47 and a negative 3. In order to subtract, I've got to subtract biggest minus smallest. So this is really 3.00 minus 0.47. I've got to flip these over because I have to do big minus small. And I have to borrow so that I can actually subtract. And the biggest one wins. So I've got x equals negative 2.53. We have fractions, decimals, and percents. Our fraction here is 3/8, and we need to make this be a number that is either has a 10, 100, or 1,000 in the denominators. Our magic number for eighths is 125. So we can say times 125 and times 125 so that we can get a fraction over 1,000, because that will give us a decimal. And 3 times 125 is 375. And 375 over 1,000 is really 0.375. Now, if you don't remember this number, what's another way I can do it? Well, I can do this long division. The top number goes in the house because it's king of the hill. And I'm going to stick these on it just in case. And I'm going to stick my decimal right there. 8 goes into 30. 3 times, that's 24, 6, that's a 60. 8 goes into 60, 7 times, 56, 40, and a 5, 375. Now, how do I make my 0.375 into a percent? I'm going to take this and I'm going to move it over twice. And I have 37.5%. I'm going to take my 0.6 and I'm going to move it over twice. So I have I have 60%, because I'm going to stick that 0 in there. How do I make this into a fraction, though? Well, this is 6/10. There's one spot after the decimal, so there's 1 0 in my denominator. 6/10 is 6/10. But I've got to say divide by 2, divide by 2. I really have 3/5, because I have to simplify this. Here I'm going to start with the percent. So I know right here that there's an imaginary decimal that I'm going to move over 2 times. This becomes 0.42. And because there are 2 numbers after the decimal point, this 42 actually goes over 100 with 2 zeros. And I've got to divide by 2, and I have 21 over 50. This number also has an imaginary decimal point here, and we're going to move this over 2 as well. This is going to become 0.03. Don't let this be 0.3, because that's a very different number. This number is 3 over 100, not 3 over 10. 2 spots, 2 zeros. And they don't have anything in common, so that is simplified. All right? And there's chapter 5. Here are all of the chapter 6 problems. Are they proportional? Solve for x. Find the unit rate and circle the cheapest one. And then a word problem. quick answers. In order to find out if they're proportional, there's two ways to do this. Either you can find a common denominator and work a problem like they are fractions, or you can use cross products. And if the cross products are equal, then the problems are proportional. For example, this one, I can actually say 15 times 4 is 60. So 9 times 4 is 36. And because of this, I know that yes, they are proportional. However, I can't make 37 into 46.25. So here I'm going to use cross products. So I want to work 37 times 40. Does it equal 24 times 46.25? And I'm going to get out my calculator, and I'm going to find that no, they don't equal at all. So these are not proportional. Here, I'm actually going to solve the problems. Now, in order to do this best, again, unless you can find a common denominator, you're going to need to use cross products. So, 18 times x equals 15 times 27. So, 18x equals 405, and you're going to divide each side by 18 so that you can get x equals 22.5. Here again, we're going to use cross products. 120 times x equals 7 times 3/7. Well, I'm going to stick that over 1, and I'm going to cross cancel, and this number actually becomes 3. So 120x equals 3, and I'm going to divide each number by the number that's multiplied to my variable, and I'm going to reduce this, and x equals, divide by 3, x equals 1 over 40. Which is the cheapest? Well, we're going to start by finding cost per ounce. How much does 1 ounce cost? And this is the biggest mistake people make, is they don't know which of these numbers goes on top. I want cost per ounce. So we're going to do 379 divided by 32, and 499 divided by 48, and 659 divided by 64 in our calculators. And when they magically appear, we realize that this one is the cheapest. Then we go over here. Kevin burns 200 calories playing Frisbee for 3/4 of an hour. How many calories would he burn if he played for 1 1/3 hour? So I'm going to set this up like a proportion. 200 calories for 3/4 of an hour. And the other question is, how many calories, x, if he played for 1 1/3 hour? So we're going to take the numbers and we're going to set up cross products. So 200 times 1 1/3 equals 3/4 x. Well, I need to do my circle thing here. This is really 4/3 and 200 over 1, and I can't cross cancel here, so I've got 800 over 3 equals 3/4 x. I have a 3/4 multiplied to my x, so I'm going to divide it away, and that means I'm going to flip and multiply. So I'm going to multiply both sides by 4/3. So I can't cross cancel here because I picked really lousy numbers. So moving over here, we've got 3,200 over 9 equals x. And 9 goes into 3,200, 355 times 0.56. And that's how many calories he burned.